Hi everyone, welcome back. Welcome back. Cheryl here again. On with the masterclass recordings, and it's now time for something on learning unit 6, which is expected value theory. So first of all, what is expected value theory? And why do we do it? So expected value theory, I'm just trying to, find my correct question. This one. When we have uncertainty, which is very much the case in the business world, then we need to take account of the uncertainty. In other words, find a way to bring uncertainty and risk into our calculation, because it would be exceptionally forgetful and irresponsible, rather, to ignore the risk associated with a decision. So what expected value theory does is we take a monetary amount and we multiply it by the probability of its occurrence. And that is going to give us a weighted value. And then in the different scenarios, and there will be multiple scenarios because this can happen, that can happen, or even something else could happen. Then we add the weighted values together, and that will give us the expected value. So strangely enough, it's not the amount that you would think or expect to get. Okay, so it's not the most likely option. It's the sum of the weighted values. So what we need to do is either use a value and multiply by the probability and then add, or as in this scenario here, that's why I've deliberately picked this one, because it's more intense kind of a calculation where it's up to us to determine the monetary amount. Once we've got that, then we will simply multiply by probabilities and off we go. So there is a question very much like this in the textbook. It's question 6.2. But I just want to do a slightly different spin on it. So let's have a look at what is required. We want a summary showing the forecasted, and remember, it must be forecasted because we're dealing with the future, and with the future comes uncertainty. So it's just the expected or the forecasted new margin for the company, and it says in each possible outcome. So we need to determine what the possible outcomes are and then get ourselves set up doing a calculation to find out what the margin is going to be. So let's have a look at what the various permutations or combinations are. In this table over here, the demand level can be one of three things. Either high, in other words, sales are good, or medium, or low. Which of it is going to be true? We don't know. So there's a question mark here on the demand level, hence the uncertainty. That's why we're going to calculate expected value. So what happens over here is this business is using heavy-duty cranes. There, that's the equipment. They now have an option. They can either buy the equipment or they can hire them. So we now have to look at that. Either hire or purchase. And it's going to boil down to the usual story. We will make the decision that is the most cost-effective or the most profitable. So we have various schedules here, various options with demand. As we said, it can be high, medium, or low. So now based on that, the business has got to decide what size crane to hire. A big one, a medium one, or a small one. And obviously the size of the machinery must match up to the demand level. So we're going to have several scenarios. We could calculate based on demand level being high, low, or medium. And we need to match that up with each of the size cranes that we hire. So if we hire the large crane, sales can be high, medium, or low. If we order the medium size crane, sales can be high, medium, low. If we hire the small or the low size machine, sales can be high, medium, or low. So you see there all of the possibilities, and there are lots of possibilities because of the uncertainty. So we're going to get all of this sorted out by, first of all, in part one, finding what these values are, and then in part two, make a decision based on maximizing expected value. So let's set up in a nice, rather complicated table over here. So first of all, we're going to look at the crane level. That's the machine. So either high, medium, or low. Sometimes, to my mind, it makes more sense to talk about large, medium, and small, but let's just go with how it was there in the book. Then we're going to have the options over here, like that. So under the high or the large crane, there's the three possibilities for the demand. Then, if we come to hiring the medium size crane, once again, high, medium, or low. If we take the small crane, sales can be high, medium, or low. So those are what we mean by each of the possible outcomes. So first of all, we got to look over here. We are needing to do a calculation to come up with the amount at the end there. And the question, remember, was asking for margin. So what we're going to look at here is we're going to get our contribution margin. And then from that, we are going to subtract the rest of the costs. For example, the higher cost. And there will also possibly be a penalty if applicable. Now let's go back to the question to see what I mean by that. So it says here, in this column, here is the higher cost. So no matter what, we have to pay upfront the higher cost in order to obtain the equipment. However, it does tell us in here, this is the important bit, if the demand exceeds the size crane that we have hired, then there's going to be additional costs over here to hire a bigger machine. If, however, the sales demand turns out to be lower than expected, there will be no refund. So what we got to do is we got to get the contribution, we got to minus the higher cost, and then work out if there is a penalty or additional cost or not. So the first thing we've got to do is we've got to go, we have to change the information because we don't have what we want. Step one is we need to go from turnover. And remember, turnover is just another word for sales. We must go from that to contribution. That is the very starting point. And contribution takes off the variable cost. So over here, we're going to have a look at this piece of information. This one is really important. It says the contribution margin is 60% of turnover. So if you remember from the recordings I made in Learning Unit 5, contribution margin, once you've deducted your variable cost from your selling price. So now, if we are told what that percentage is, we can then go and work out what the contribution is. So if we know that the contribution margin is 60% of turnover, very easy to find the amount of the contribution by finding 60% of turnover. Because we don't have information here to go the usual way. So we don't have selling price, we don't have variable cost, so we can't get contribution that way. But by seeing the given contribution margin percentage or marginal income ratio, if you remember how we did that in the previous recordings, then we can go from turnover to contribution. Just be careful with this one. Yeah, read it very, very carefully as to whether you are given the contribution margin like this one, or if you have the variable cost percent. Looks like a typing mistake in there. Let's correct that quickly. So if we are told what percentage the variable cost is of the turnover, that's a different story. Remember, that's your marginal cost ratio. There, your marginal cost ratio. Make sure that you remember all of the concepts from learning unit 3. And we looked at it there when we did break even. So your marginal cost ratio would be the same as the percentage variable cost. So let's say they gave you that. Then you mustn't use that. You must then get contribution margin. So let me just make up another possible scenario. If it says that variable cost is equal to, say, 70% of turnover, what must we therefore go and do? We must subtract that to get the contribution margin. And then contribution margin will be the other 30% of turnover. But we're not going to do that here because it tells us the contribution margin, and that is 60%. So step 1 is we're going to take all of these values here, the turnovers, and we're going to multiply them by 60% to change them into contribution under all of the possible outcomes. So I'm not going to take you through that. It's a bit long-winded and very simple. So do have a look here. These amounts, the 30 million, 25, and 10, they are the same regardless of the size crane that we hire. So step 1 is we're going to find 60% there, and that is going to give us the contribution. Then you see here, we're going to repeat that down here. And lastly, again, so that part of the working is always the same because we're going to calculate the contribution. Next up, we need to look at the higher cost. So we're going to come over here to the large machine, and we see that the higher cost is 4 million. So that's the next step. We're going to see over here, minus 4 million, minus 4, minus 4. Now, let's see if there is ever going to be a possibility of a penalty. And remember that we only incur this extra cost if the size equipment we have hired is too small to satisfy demand. And in this case, that won't ever happen, because with the large crane, whether the sales are low, medium, or high, that will be big enough to be able to handle production. So there will never be any penalty. So then we can get to the numbers on the far right-hand side. we're going to subtract the higher cost from the contribution, and that will give us these three figures over here. Now let's have a look at hiring the medium-sized crane. Step one, as I said, we're going to change the turnovers to contribution. Now we have to obtain the crane, so that means we need to hire it. And in order to hire it, what are we going to see? It's going to cost us 3.5 million. So in each of the alternatives here, we are going to minus 3.5, minus 3.5, minus 3.5. Last part of the calculation, is there a penalty or not? So we've got the medium-sized machine. If sales are low, the machine is big enough, as is if the sales are medium. The only time we run into a problem is with the medium-sized machine and the sales level turns out to be high. Then we would have to hire additional equipment and pay that penalty. So we now need to find what is that cost for medium to high. So let's make sure we read this carefully. It's this one here in the middle. The additional cost of medium to higher is a further 1.5 million, but it only applies in the case of high. So you can see over there, as well as that higher cost, there's also the subtraction of the other 1.5 million. Then carry out the calculation, and that will give us those three numbers on the far right. Lastly, we're going to do hiring the small machine or low. To repeat, we're going to get the contribution, 60% of the turnover. We need to hire the machine at a cost of 2 million. So we're going to, in each of the outcomes, subtract 2 million, subtract 2 million, subtract 2 million. Now let's try and find if there is a penalty. Not in the case of the small machine and the sales being low. Only here, this is one. The small machine is not big enough for the medium sales. So we're going to have that penalty, low to medium. Let's find that. Here is low to medium, and that's an additional 900,000. So let's see where we're going to put that in. There, minus 900,000. There will be another situation over here. In the case of it being high sales, we definitely are not going to be able to cope with the small machine. So we must find the additional cost associated with low to high. And there it is. Low to high is a further 2 million. So that's why here we have a double deduction of 2 million. One is the advanced higher cost. The other one is the additional penalty. So we're going to go then and calculate the final set of three values. And that will be the answer to part 1. So that is a summary in the form of a table, and it shows the new margin, in which case we have sorted out the penalty as well as hiring it in each of the three possible scenarios. Next up, we need to use that to answer the question of what machine should they hire. So we need to work out expected value, because that is the way that we deal with the uncertainty. So those values that were at the far right-hand side of the first part, we're going to start with those. We're going to multiply them by their probabilities of occurring, and we're going to add them. Based on that, we're going to maximize expected value by picking the biggest one of the three values. And that will match up with the correct size crane to hire. So the only thing that is missing that we haven't had a look at yet is this information over here, the probability there. So there's a 70% chance of demand being high, 20% medium, and finally 10% low. So now what we're going to do is we're going to take all these amounts that were here, there with the blue around it, and we are going to pop them in down here. So remember, we have got the 3 scenarios again: high, medium, and low. And we're going to have the sales levels also being high, medium, low. So the first part of the table is the same. And now what are we going to do? As I said, we're going to take these numbers that we've just been working with. I'll have to find another color. Let's take this one here. This 14 million is the amount associated with high sales and a large crane. So these 3 values over there, we're going to copy and paste them there. Then let's have a look at the next one. We're going to take these 3 values that go together with the medium, and we're going to copy and paste those and put them there. Then we're going to do the same here. These 3 values there go together with the low. We're going to copy and paste them next to low. That was the reason for answering part 1. Now we're going to take them and we're going to weight them by multiplying by the probability. And you remember how that went. 70% for high, 20% for medium, and 10% for low. So we do those calculations, and then that is going to give us these 3 values there. So those are now the weighted values. Let's just type that in here. Weighted means we have taken the amount and we have multiplied it by its probability. Then let's work out the expected value, because after all, this is the purpose of this question. We are going to do this. Work out the expected value, which is the sum of the weighted values. Let me type that in for you in case you missed that. Expected value is the sum of the weighted values, let's say, in each outcome. So those amounts that we have just worked out, we're going to add them. And that is that answer. Then we're going to do the same for medium, same for low, and all I'm interested in now is this, the sum of those weighted values. Over here. So I can't actually get down there. There's too much happening in there. It's wanting to pick up the wrong thing all the time. There. Got to circle it. So now we are in a position to be able to advise management on the best possible decision. So we have an expected value of 12.2 million for high, 11.65 million for medium, and 12.62 million for low. So on the basis of maximizing expected value, we pick the largest one, which in fact is the low. So to answer the question, we'll say management should accept the low contract, and always remember to back it up with a reason. because it gives the highest expected value. Please go and practice this by doing question 6.2 in the textbook. You might find something similar in a past exam paper as well. So there we're going to conclude the first of my recordings coming from Learning Unit 6. The second one is going to be on a decision tree, which is a graphical depiction using expected value calculation. So until then, from me, for the moment, it's cheery bye. See you soon.